So we're looking at day 17 summary. On day 17, we're looking at composite perimeter, so perimeter of composite shapes, and the area of composite figures. So starting out the perimeter of a composite shape, the first thing we should do is figure out all the exterior sides, determine the length of those sides, add up all the length of the exterior sides, and use your formula sheet to help, but you don't usually use it for much. So I'm going to look at the very first one here, which is a funky heart shape. And so first identifying my exterior sides. I'm going to add up, these are my sides that I need to add up. I need to know the length of all those sides. So I'll start with the easy one. I'll label this side. Since there's little tick marks on these sides, this one's also going to be 12 meters in length. Now, the dotted line sides are also 12 meters in length, but for a circle, well, actually I need that. So 12 meters here and 12 meters here. But I need to know the exterior. So each of these. So I'm just going to do the circumference formula. Since I have the diameter, I'm going to use the formula pi d. And for each of those circles, I'm really splitting that in half. So it's half of pi d. So that's going to be equal to pi, which is 3.14, times the diameter, which is 12. And then we're going to divide that by 2. So get out your trusty calculator, 3.14 times 12 divided by 2. Gives us 18.84 for each of those sides. So I'll write that on there, 18.84 for this one and 18.84 for this one. So my total perimeter, I'm going to pick a spot as my starting spot, maybe here. I'm going to walk along the outside. So first I have 12, then I have my semicircle, 18.84. Then I have another semicircle, 18.84. And then I have this side over here, which is 12. So I'll type all that into my calculator. And I get 61.68. And I want to round to 1 decimal place. So that's looking at the 8 means that this number is going to go up 1. Because the 8 is greater than 5, so this is 61.7 meters is my perimeter of this shape. We'll go down on the page and do the next perimeter. A garden is in the shape shown below. Determine the amount of fencing needed to enclose the garden. Well, fencing is really perimeter, so once again I want to look at what I need. So I need this side, this whole side, this diagonal, and this semicircle. Okay, so let's start with the semicircle. We just did one of those, so I'm going to use C equals pi d divided by 2 because it's a half a circle. So in this case, 3.14 times 30 divided by 2. Type that into my calculator. And we get 47.1 meters, and I'll write that right on my picture. 47.1 meters is this part here. Then I need this diagonal. Now that's a little more challenging. We know it's not going to be 15 because it definitely looks longer than the 15 side. So I'm going to close that off to try and figure that out. And notice that what I have here is a right angle triangle. If this is 30 across here, and this is 48, I can subtract 48 minus 30 to get that side, which means it's 18 meters. And this side is parallel to this side, so it's going to be 15 meters. So I see a right angle triangle with the hypotenuse missing. So I'm going to use my Pythagorean theorem. C squared equals a squared plus b squared. This will be A, this will be B. So I have C squared is equal to 15 squared plus 18 squared. C squared is equal to, we're going to square 15, which is 225, and we'll square 18, which is 324, And then we need to add those together. So we have 225 plus 324 gives me 549. And then remember, you're not done yet. You need to find the square root of both sides. When I square root c squared, I get c. And when I square root 549, I get 23.43 approximately. So I'm going to take that measurement and write it on my diagram too. 23.43 is that side length. And now I have all my sides. So I'm going to walk around the outside. Do that in purple. So I'll start in this corner. First I have 48 across. The perimeter is equal to 48. And then I have the diagonal here, which is 23.43. Then I have this semicircle plus 47.1. And then I have 15 plus 15. Notice I didn't include the 30 in the middle. Adding that all up in my calculator. I get 133.53, and rounding to one decimal place, I notice that this 3 is less than 5, so it'll round down. So that's 133.5 meters around the outside. So that was my perimeter. Let's look at the area relationships. Zoom in over here. So to do composite areas, we're going to determine or figure out our shapes, identify all the shapes, and then calculate the areas of each of the shapes, and then decide whether we're going to add or subtract those areas. So if I look at this first figure, I see a trapezoid on top. That's one shape. And I see a parallelogram on the bottom. So I'm going to call this A1 and this A2. So let's go about finding the area of each of those. So A1 is a trapezoid. Its area is 1/2 of the top, which is 15, plus the bottom, this side, which is parallel to this one, so it's 45, times the height, which is 30. I should have written the formula down first. Oh well. So I have 1/2 of 15 plus 45 is 60 times 30, and I can do all that in one step. So 1/2 is like 1 divided by 2, or 0.5, times 60 times 30, which gives me 900 for area 1. For area 2, the area of a parallelogram is just the base times the height. So the base is 45, and the height is 15. So I'm just doing 45 times 15, nothing special there, 675. So the area total is going to be A1 plus A2, area 1 plus area 2, which is, and I'm adding them because they're two pieces that I put together. And I'll do 900 plus 675 to give me 1575, and my units are squared, so in this case centimeters squared. So that's my area of the first figure. Second one's slightly different. As you can see, this is a rectangle with two circles cut out. So if I'm identifying my shapes, I'm going to see, let's see, I have a circle, call that A1. A2 is my second circle, which is the same size. And then I have a rectangle on the outside. What am I going to call that rectangle on the outside? We'll call that A3. So let's start with A1. A1 is going to be pi times r squared. We need the radius. Well, I see on the side that it's 12 centimeters from one side to the other. So half of 12 centimeters will give me the radius, which is 6 centimeters. And that's the same for both of them. So that's 3.14 times 6 squared, or times 6 times 6, if you want to type it in separately. Don't forget to press equals, is 113.04. That's area 1. Area 2 is the same, so I'll just write that down so I don't forget it. And area 3 is a rectangle, and that's length times width, which is 24 times 12. 24 times 12 gives me 288 for my rectangle. Now to get my total area, I'm going to take, or the area of the shaded part, let's call that area shaded. That's going to be A3 minus A1 and A2. So I'm going to do 288 minus 113.04, and I'll do the minus again. Type that all in my calculator. And I get 61.92. Now I want to round to the 9. The 2 is less than 5, so it stays the same. So it's 61.9 units are squared, centimeters squared. So that's the area of that shaded region there. Subtraction, because we're taking out those 2 circles from the big rectangle. Today we also looked at the volume of a sphere, and so that was the online lesson, or the video lesson, and we'll remember that the volume of a sphere is 4/3 pi r cubed. So for the first one we need our radius, so we have to take that 19 and divide it by 2. So my radius is 19 divided by 2, which is 9.5. So my volume is 4 divided by 3 times pi, 3.14, times 9.5 3 times. 9.5 times 9.5, or 9.5 cubed. So we type 4 divided by 3 times 3.14 times 9.5 times 9.5 times 9.5, and we get 589.54333. Rounding that to one decimal place, the 4 is less than 5, so the 5 here is going to stay, so 3,589.5, and this is 3-dimensional, so it's inches cubed. Our second example is a half a hemisphere, so we're going to divide our volume by 2. We're given the radius is 24, so we're just looking at 4/3 times pi, 3.14, times the radius. Ooh. And then I want to divide that answer by 2. Is that going to fit on my page? No. Divided by 2. Just squeeze it on the end there. So we're typing 4 divided by 3 times 3.14 times 24 times 24 times 24 divided by 2. All in one step. That's a big number. 28,938.2 when you round that. That's approximate. I forgot my approximately sign back here. And that's feet cubed, because it's a 3-dimensional figure. Its units are cubed. 3-dimensional figures have units cubed. That's it for today. Have a good day.